In this lesson video, we're going to be going over your Algebra 1 Semester 1 exam review. The first part with no calculator. There are 20 questions on here, so it's going to take a little bit of time, but you can always skip ahead to certain problems you had questions on. All right, so for 1 and 2 here, and it gives you what standard is being covered for each of these questions. As a favor to her friend, Natasha worked 7 hours at a diner for $10 an hour last week. She also makes $8 an hour babysitting. She wants a $206 prom dress, so create an inequality to show how many hours she must babysit. We already know how many hours that she worked at the diner, right? At a diner. We know she worked 7 hours, so we're only looking for one thing here. So if she makes $10 an hour at the diner, that's $10 times X, we'll say, because that's the amount she makes at the diner. But in this case, we know how many hours she works, right? It's $10 per hour, and we know she worked 7 hours. So 10 times 7, plus she makes $8 an hour babysitting. So 8 times Y. I got to give them two different variables. Sorry, I had a phone call. For this one, we want to use two different variables to represent the hours she worked at the diner and the hours she babysat, because they're two different things. And in this case, we know how many hours she worked at the diner, so we're going to use a variable for how many hours she babysat. And it doesn't matter what letter you use. But together, all of that money she earned has to be at least $206. She can't make less than $206 because that's how much her prom dress is. She can work hard and make more than that, but she has to at least make that. So the amount of money she makes has to be greater than or equal to $206. So this is our inequality, and now we want to simplify it. And I'm actually going to use a scratch sheet of paper here. And this is going to be 70 plus 8y is greater than or equal to 206. And then we're going to subtract 70 from both sides. So we get 8y is greater than or equal to 136. And then we can divide both sides by 8. So y is going to be greater than or equal to 136 divided by 8 is 17. So the hours that she babysits has to be 17 or greater. She has to work more than or equal to 17 hours in order to make enough money for the $206 prom dress. So we're going to say y greater than or equal to 17. And we got this from simplifying this original equation. Okay, for number 2, George makes $5 per autograph, and they give you the variable, and $8 per hour working as an actor at a local theater. He needs $730 for rent. Create an inequality to show how much he needs from each source of income. Okay, so here, $5 times the number of autographs plus $8 times the number of hours he works as an actor. Together, all that working, all that money income has to be greater than or equal to $730, right? It could be equal to $730, but he could also make more than $730, but he cannot make less, because if he does, he's going to get kicked out, right? So this is our inequality, and we can't simplify any more than that because we don't know what A or C is. We have two different variables. Number 3. We've got our graph here. Write an equation to show the relationship between the length of the room in feet, which is R, and the length of the room in inches on a blueprint, right? So this is our y-axis. This is our x-axis, and up and down, this is our y-axis. So instead of the letters X and Y, I'm going to use the letters B and R, right? So first off, to write an equation, to write a relationship, I'm going to think y equals mx plus b. Okay, where this is the slope, this is the y-intercept, right? So here, I'm crossing the y-axis at 0. So y equals mx plus 0. And my slope, I'm going to try and look to see where my line goes in through the corner of a box. And it looks like right here. So when the length of the room in inches on the blueprint is 2 inches, that represents 5 feet of the actual room, right? So my slope is rise over run, up 5 over 2. So y equals 5 over 2x. right? And then we're not using y and x, we're using b and r. So r equals 5 over 2b. The amount of feet in the room is equal to 2.5 or 5/2 times the number of inches used on the blueprint, because the blueprint's a lot smaller than the actual room. Number 4, write an equation in slope-intercept form, y equals mx plus b, for each of the following lines to show lines shown on the graph. Okay, so for this first guy, for y equals mx plus b, I'm going to start by figuring out what's my y-intercept. That's b, right? Wherever I cross the y-axis, that number is b. So here I cross the y-axis at -1. So y equals mx minus 1. b is -1. Then I want to figure out my slope. So from here to the next point on my line, which is about right here, I'm going to go up 1 over 2. So y equals 1 over 2x minus 1. This is my equation of my line. If I had this equation and I wanted to graph it, I'd start off at -1, and then I'd go up 1 over 2, up 1 over 2, and this would be my line. Okay, next one, same thing. Y equals mx plus b. b is my y-intercept. On this graph, I'm crossing the y-axis at +2. So y equals mx plus 2, because if I started at 0, 0 and went up 2, this is where I crossed the y-axis. And then I want to figure out the slope. So from this point to get to the next point on the line, which is right about here, I'm going to go down 2 over 1. Down 2 over 1. So y equals -2 over 1, x plus 2. And you don't have to write the 1, right? You don't have to write it that way. You can just simplify. Y equals -2x plus 2. There's my equation. I start off with plus 2 on the y-axis. Put it here, and then I'm going to go down 2 over 1, down 2 over 1. This would be my line. All right, number 5. Bart wants to rent a car. The fee is $25 plus 55 cents per mile. He budgeted $212 for the car. That means he only set aside $212. He didn't say, I don't care how much it is, just tell me and I'll write a check, right? He said, okay, I'm saved up. All I have is $212. So what can I do for $212? Write an inequality to show how much he can spend for the car. So he's going to spend $25 plus 55 cents per mile. 0.55, we can say m. And together, that has to be less than or equal to $212. Less than or equal to 212, right? Because all he has is 212, so this can't be more than 212. Between the payments and the gas, it can't be 500. He doesn't have 500. This has to be less than or equal to 212. So this is our equation right here. And then you can simplify and solve for m easily, but this is the inequality. All right. Number 6. Solve the following equations and explain each step using the appropriate properties. And I'm gonna use separate, here, I'll do this over here. I'll use separate paper so I can write out the steps. All right, so for number 6, A, we have 5 times 4x minus 3. Minus 18 equals 7. And we're going to use order of operations to solve here. So the very first thing I need to do is distribute this 5, right? This is going to go here and here. So 5 times 4x is 20x. 5 times -3 is -15. And then I still have that minus 18 equals 7. So what did I just do here to get from here to here? I used the distributive property. And I'm going to abbreviate. Distributive property. What do I need to do next if I'm solving? I need to combine like terms, right? So that's going to be 20x, -15 and -18 is -33, equals 7. All I did was simplify. So whenever you simplify one side, it's substitution. It's not a property of equality because I didn't even touch this side. I only replaced this with a value that is equal to. That's substitution. All right, next I want to get x by itself. So I'm going to add 33 to both sides. I'm going to add 33 here. So when I add 33 here, it's going to go away. When I add 33 here, it's going to become 40. So 20x equals 40. How did I get from here to here? The addition property of equality. Whatever I added on one side, I added to the other. Now, you could write out that step. I could write 20x minus 3 plus 33 equals 7 plus 33. And that would be the addition property. And then when I simplify in this step, that step would be the substitution, right? But instead of having it in two different steps, I'm lazy, I want to condense everything. So I'm just going to go ahead and do it in my head. And I'm going to add 33 on both sides of my head, write the answer down. How did I get this answer? I added 33 to both sides. So that's the addition property. Okay, next thing I need to do to get x alone is divide both sides by 20. So when I divide this side by 20, the 20s cancel out. 40 divided by 20 equals 2. And that's the division property of equality. Okay, hopefully that's making sense to you. B. This is 3 times 2x minus 7. Minus 4x equals 19. Okay, same kind of deal. We want to first get rid of parentheses, so I'm going to distribute. So I will have 6x minus 21 minus 4x equals 19. And that's the distributive property. I'm abbreviating. If you wanted to write given up here in the top, you can. I just leave it blank because, I don't know, don't really need to write given, but we all know that that's given to us. So the first step is distributive property. What do I need to do next? Combine my like terms. So 6x minus 4x is 2x minus 21 equals 19. And all I did was replace 6x minus 4x with what it's equal to. So that is substitution. And now to get x alone, I want to add 21 to both sides of my equal sign. I'm going to do this in 2 steps just to show you what I mean, like up here. And then I'm going to cross out what you don't need. So 2x minus 21, and then I'm going to add 21 equals 19 plus 21. And since I'm adding 21 to both sides, that's the addition property of equality. And then in the next step down is where I want to simplify. So these cancel each other out, and I'm left with 2x. 19 and 21 is 40. And I would just write substitution. So what I'm saying that you don't need, let's see if I have a red pen. Let's see if this one works. You don't need this whole line. You can just go straight from here to here. You can do this in your head. And if you do that, you don't need substitution. You just keep the addition property of equality. How did I get from here to here? I added, right? Which is what we did here. This and this are kind of like extra, right? We did these in our head. So we're just going to keep these. I hope that's making sense. All right, and then lastly, I want to divide both sides by 2. So x equals 20. That's the division property of equality. All right, hopefully that's making sense for you. Let's go back to our test. Okay, and then I have number 7. Now I have 2 inequalities. I have to write the inequalities from the graphs of those inequalities shown. Okay, so I want you to think of this as y equals mx plus b. Let's just focus on this one first. Y equals mx plus b. Okay, y is the shaded part. So y is our shaded part. Is the shaded part above the line or below the line? It's below the line, right? So the shaded part is less than my line. My line is represented by mx plus b. That's my line. Okay, next thing I notice is that it's a dotted line. So on my inequality symbol, I'm not going to put the line underneath. If it's a solid line, I put the line underneath, but this is dotted, so I don't. Okay, so now I just need to come up with, for this line, what's my y-intercept and what's my slope. So y is less than mx plus b. I go through on the y-axis, I go through 0. So B is just 0. And then my slope looks like it goes up 1 over 2. Up 1 over 2, right? Up 1 over 2, up 1 over 2. Every time I go up 1 over 2, I land back on my line. So 1 over 2x plus 0. 0 is my y-intercept. And then I don't have to write plus 0, so it's just y is less than 1/2 x. Here's my inequality for this graph, okay? Next graph, it's the same number. Same thing, so we want to use y equals mx plus b. Here, y, the shaded part, is above the line. It's higher than the line. So my shaded part is going to be greater than my line. And since it's a solid line, I'm going to put a line underneath here. So it's going to be greater than or equal to my line. Okay, so now I need the slope and the y-intercept. Where does this line cross the y-axis? At -1. So y is greater than or equal to mx minus 1. B is -1. Now I want the slope. So going from, let's say, here to the next point on my line, which looks like here, or maybe here, or it could be here or here, I'm just going down 1 over 1, down 1 over 1, down 1 over 1. So my slope is -1 over 1. Y is greater than or equal to -1 over 1x minus 1. When it's just a 1 in front, you don't have to write it. -x minus 1. That's this graph. Okay? Number 8. I'm trying to go quickly so I'm not too boring and don't lose you guys. All right, determine whether each graph shown is a function. This is not multiple choice, so you have to answer them all. Whenever you have a graph, you have to use the vertical line test. So anywhere I draw a vertical line, it should only cross the graph in one spot, right? And here it only crosses this curved line in one spot each time I draw a line, right? Only touches it once. So that one is yes, this is a function. Same thing here. Anywhere I draw a vertical line, it only touches my graphed line in one spot. So yes, this is a function. What about these two? Anywhere I draw a vertical line, does it only up? This touches my graph in 2 places. So no, this is not a function. It can only touch my graph in 1 place. Boom, done. This touches it in 2, so it's not a function. Same thing with my circle. If I draw a line through here or here, anywhere, I'm going to hit it in 2 different places. And if that happens when you draw a vertical line, then it is not a function. So D and C are not functions, A and B are. All right, number 9. Which of the following tables represents the function y equals -4x, -4x squared? So basically, I'm going to find one ordered pair in each table, right? When x is 0. You can pick any one, doesn't matter, but the x values need to be the same. So I could pick -2, 0, 2, or 4, doesn't matter which one. I'm going to go with 0. So here in this table, when x is 0, y is -4. And in this table, when x is 0, y is 0. So what I need to do in my equation here is plug a 0 in for x and solve for y. If y is equal to -4, then I know I use this table. If y is equal to 0, I know I use this table. If it's not equal to either one, I know I don't use either table. Y equals -4 times 0 squared. Excuse me. Y equals 0 squared is 0. And 4 times 0, anything times 0 is 0, so y equals 0. So when I plug in a 0 for x, y equals 0. So this is not going to work because this says y has to be -4 when x is 0. So this is the table that I will use. Okay, number 10. Jax threw a ball off a roof of his treehouse. The height, y, in feet of the ball and the time, x, in seconds, is shown in the table. Interpret the y-intercept of this function. Y-intercept is whatever y is when x is 0. So let's find where x is 0. Here it is. Okay, and also we know that x is time. It's how many seconds. It says the time, x, in seconds that it takes for the ball as it's moving, right? So when it's moved 0 amount, The ball hasn't even started going yet. It's been nobody started the clock. It's been 0 seconds. The ball's already 11 feet in the air, right? It says height in feet. So when x is 0, y is 11, and it says that he threw a ball off the roof of his treehouse. So this tells us that the treehouse roof is 11 feet up in the air. Because he's just standing there, right? He hasn't even thrown the ball yet, and the ball is already 11 feet tall. So that means he had to have started at 11 feet tall. Okay? Number 11, same kind of thing. We have to interpret the table. Kate received $15 from her Nana on her birthday. Excuse me. Kate used this money to open a bank account and added money each week as shown in the table. Interpret the y-intercept of the graph of this function. The y-intercept is whatever y is when x is 0. So here's x is time. Here's our x, y. When x is 0, y is 15. What does that mean? When it has been 0 time, no time has passed. I literally walked in the bank and said I want to open an account. It's not sat there for any amount of weeks. It's brand new. It automatically starts with $15 in it. So my y-intercept here says that I open the account with $15. I don't, but you know what I mean. The account is open. Open the account with $15. It's not like the account was at 0 and then time started passing by and then you started adding money. The second you opened that account, you had $15 to put in it. So that's our y-intercept. Okay, number 12. Find the average rate of change. For the following temperatures in degrees Fahrenheit recorded beginning at noon. Also interpret the meaning of x equals 3.5. All right, so time is x and y is our temperature, right? So it says it starts at noon, and does it say it's in hours? I would guess if it starts at noon, that's when time is 0, starts at noon, and then 0.5 would be like half an hour later. And then 1 would be 1 hour later. 1.5 would be an hour and a half. 2.0 would be 2 hours later, right? So this would be noon, 12:30, 1, 1:32, 2:33, 3:30. So when x equals 3.5, 3:30 p.m. because it says the whole thing started at noon. Okay, and then it says what's the average rate of change? Rate of change is slope, right? And remember, slope is y minus y over x minus x. And it asks us to find the average rate of change from 0 to 3.5. So I'm going to use this and this guy. Okay, so this is xy, this is xy. So y minus y is going to be, let's say, 62 minus 45 on top, and then x minus x on the bottom. Since I started with 62 on top, I have to start with 3.5 on the bottom, minus 0. Okay, and then, what did it say when x equals 0.5? My bad, sorry. It says from this amount, not when x equals 0. So here it's 47 degrees, 62 minus 47. And the time would be 3.5 minus 0.5. A little tweaking there. Okay, so 62 minus 47 is 15. 3.5 minus 0.5 is 3. And if I simplify that, I get 5 over 1. And remember, our y value is degrees. So 5 degrees, it changes 5 degrees per hour. 5 degrees per hour. And if you think about it, I mean, if we go from here to here, because this is just a half hour, so if we go from 12:30 to 1:30, it went from 47 to 55, that's 8 degrees. 1:30 to 2:30, 55 to 58, that's just 3 degrees. So now it's an 11 degree change. Divide by 2, that's about 5.5, close to 5 degrees. And then 2:30 to 3:30, it went up 4 more degrees, right, which is close to 5. So it changed on average, it's about going up 5 degrees per hour. Hopefully that's making sense for you. Next one. Number 13, I know this is taking a while. I'm trying to hurry, I'm sorry. Find the x and y intercepts for each of the following. This is not multiple choice. Let me get a scratch sheet of paper. Number 13. All right, for A, we want to find the x and the y intercepts. Basically, for the x-intercept, plug a 0 in for y and solve. For the y-intercept, plug a 0 in for x and solve. That's all we're doing. So 3 times 0, minus 2y equals 6. This goes away. Negative 2y equals 6. Divide both sides by negative 2. Y equals negative 3. So my y-intercept is 0, negative 3. And then for x, I'm going to plug a 0 in for y and solve for x. 3x minus 2 times 0 equals 6. So that means this goes away. 3x equals 6. Divide by 3. X equals 2. So my x-intercept is 2 when y is 0. All right, and then for b, I'm going to solve it the same way. Negative 2x plus 5y equals 7. I'm going to plug a 0 in for x to solve for y. And this goes away, so 5y equals 7. Divide by 5, divide by 5. Y equals 7 over 5, or you can change it to 1 and 2/5. Right, so our y-intercept would be 0, 1 and 2/5 or 1.4, however you want to write that down. 7 over 5, whatever. Okay, and then for the y-intercept, for the x-intercept, I plug a 0 in for y. Negative 2x plus 5 times 0 equals 7. This goes away. Negative 2x equals 7. X equals negative 3.5. So negative 3.5, 0. That would be my x-intercept and my y-intercept. Okay? X-intercept, y-intercept. Let me know if you have questions on that. All right, number 14, find the x and y-intercepts of the following linear graph. Okay, well, that's easy. Here's the y-intercept. So the y-intercept is at 0, 2, or you could say y equals 2. And then the x-intercept is here, across the x-axis right here. And that's when x equals 3 or 3, 0. Right, so this is my, y-intercept, and this is the x-intercept. Easy peasy. Number 15, we're almost done, we're getting there. Given that, okay, this gets confusing because they don't call this y anymore, now they call it f of x. It's still y. We still treat it the same way, it's just function notation. Given f of x equals negative 2x plus 3, and g of x is shown here in the table, compare slopes and intercepts. So we'll say slopes first, and I'll say f of x will be on top, and then g of x underneath it. Okay, so what's the slope of f of x? The number in front of x, which is negative 2. Draw a line here and here. And then the slope of this guy, I have to do some math. So it's going to be y minus y over x minus x. Remember, this is y. So 4 minus 2 over negative 2 minus negative 1. 4 minus 2 is 2. Negative 2 minus negative 1 is negative 2 plus 1, which is negative 1. So 2 over negative 1, which is negative 2. Same slope. And now we want to find the y-intercept. Okay, so for the y-intercept, we know for f of x it's 3. For the table here, we want to know what y is when x is 0. So here, when x is 0, y is also 0. Okay, so they have the same slope, but they have different y-intercepts. And what about the x-intercept? Because it just says the intercepts. X-intercept. Okay, so what is x when y is 0? Well, if I plug a 0 in here, let me do the math over here. 0 equals negative 2x plus 3. Subtract 3 from both sides. Divide both sides by negative 2. And I should get x equals positive 3 over 2. Because a negative divided by a negative is a positive. and 3 over 2 is 1.5, right? So the x-intercept is at positive 3.5. And the x-intercept for the table is, what is x when y is 0? X is 0. All right, so here's our little table. We have our slopes, our y-intercept, our x-intercept. The slopes are the same for both of these functions, but nothing else is. Okay, number 16. Find the slope of each linear function shown. This is not multiple choice. All right, so for a, the slope is the number in front of x, so -5. For b, again, the slope is the number in front of x, not the plain number. It actually should be written as y equals -3x plus 2, because it's positive 2. So this would be -3. Okay, here for c, to find the slope, we need y minus y over x minus x. So I'm going to do 19 minus 13, this minus this over 4 minus 6. That's 6 over -2, which is -3 for this guy. For d, same thing, y minus y over x minus x. I'm going to do 5 minus 2 over 0 minus 1. Positive 3 over -1 equals -3. And E, table E here. Y minus y over x minus x. I'm going to use these two. 2 minus 1 over 8 minus 6, which is 1 over 2. Okay, so I've got 3 of the problems have a slope of -3. 1 has a slope of -5, and 1 has a slope of positive 1/2. Okay, when the bottom's going up, the top's going up. And then number 17 here, write a function that represents a baby's weight during the first 4 months as shown in the table, where x is the number of months after baby was born, and f of x, or y, is the weight of the baby in pounds. Okay, so this is 1 month after baby's born. It weighs 11 pounds. 2 months after it's born, it weighs 16. 3 months after it's born, it weighs 21. 4 months, it weighs 26 pounds. Okay, so we want to write a function that represents this. So y equals mx plus b. First thing I want to do is find the slope. So y minus y over x minus x. 26 minus 21 over 4 minus 3. That would be 5 over 1. So the slope is 5. Y equals 5x plus b. And what is b? What's my y-intercept? I'm just going to pick an ordered pair to plug in. So I'll pick 1 and 11. When x is 1, y is 11. 11 equals 5 times 1 plus b. Minus 5 from both sides, b equals 6. So my equation, my function, instead of y, I'm going to write f of x, equals 5x plus 6. Okay, so this represents a baby's weight X months after it's been born, which means it's gaining about 5 pounds a month, and it started at 6 pounds. So when X is 0, when no time has passed, it weighs 6 pounds automatically when it's a brand new baby. And then each month, it gains about 5 more pounds. Yeah, I think we're on the last page. We are awesome. Okay, number 18. You guys are being so patient. Thank you for bearing with me. Determine whether each function shown is linear or nonlinear and explain. To be linear, they have to have a constant rate of change. So here, x is constantly going up by 1, plus 1, plus 1, plus 1. Y, or f of x, is going up by 5, up 5, up 5. So this is constantly changing at the same amount. So yes, this is linear. And our slope is change in y over change in x, so that's going to be 5 over 1, or 5. That's our slope. Okay, for 8, don't get confused here and put x over y. It's not a slope of 1/5. It's change in y over change in x. This is y, this is x, so 5 over 1. Okay, number 8, x is constantly going up by 1, plus 1, plus 1. Y is going up by 2, and then, it goes up by 6, and then it goes up by 7. So it is not going up by the same amount at all, right? Here it changes by 2, here it changes by 6, here it changes by 7. So this is nonlinear. It's not going to create a straight line if we were going to graph all of these ordered pairs. Okay, number 19. Payments on accounts for Omar's landscaping company were going down, and Omar was concerned. Week 1, the payments were a lot. They were $1,850. And then week 9, 9 weeks later, the payments were $1,130. What was the rate of change for this time period? All right, so we're going to do weeks, comma, payment. Right? So that's our ordered pairs. So in week 1, our payment was $1,850, and in week 9, our payment was $1,130. So here's 2 ordered pairs, and to find the rate of change, I'm going to use the slope formula. Y minus y over x minus x. So 1,850 minus 1,130 over, this minus this over 1 minus 9. Okay, so that's about $720 over -8, which simplifies to -90. What does that mean? That he was losing about $90 per week in payments. Each week, the average payment was going down by $90. So losing 90 per week. Hopefully that makes sense to you. And last one, number 20, we have to look at a graph. Determine which statements below are true related to the function y equals -3 over 2x plus 9, which is shown on the graph. This is not multiple choice. We have to answer all of these. The function represents the height in feet of a helium balloon after t minutes. All right, so the initial height was 9 feet. Is that true? Well, after 0 minutes, we were already at 9 feet high. So that, yes, it started off at 9 feet. So yes, that's true. True. Okay, part B. The balloon fell 3 feet per minute. Okay, so if we go over 1 minute, we go down 3 over 1, down 3 over 1, down 3 over 1. No, that's not the same dots as the ones that are already there. That's not true, right? So that's X, false. Okay, C, it took the balloon 6 minutes to fall. So it starts off at 9 feet. By the time it's at 0 feet, how long did that take? 6 minutes. So that is true. D, the initial height was 6 feet. Did it start off at 6 feet? No, it started off at 9 feet. False. 9. And then last but not least, the balloon fell 2 feet every 3 minutes. So it's saying we're going down 2 over 3, down 2 over 3, down 2 over 3, down 2 over 3. Does that look like? Here's what they gave us. Here's the points they gave us. So do those red dots I just added match up with this line? No, they do not. So that is not true. Boom. False. What is the slope here? What is it falling? It looks like it's going down 3 feet. Is that what I said? It fell 2 feet every 3 minutes. No, it fell 3 feet every 2 minutes. It's going down 3 and over 2. Down 3 and over 2. These are the minutes. These are the feet. So down 3 feet, over 2 minutes. Down 3 feet, over 2 minutes. Down 3 feet, over 2 minutes. So this just got them flip-flopped to confuse you. If you guys have any questions at all on this no calculator portion, let me know, and stay tuned for the calculator portion.